We'll proceed in parameterization of volume, not surface, volume, Jacobian for 3D. Jac- Jacobian for 3D. So 2D Jacobian we saw. So 2D Jacobian, if I have u comma v, means I have UV plane, then how I can map it to xy plane. If I have UV plane, then how I can map it to xy plane. If I have UVW plane volume, then how I can map into xyz. So prior to that, I would like to repeat the three proof of Jacobian that we have given. Two are from book, one is from ourselves. And from book, if you proceed from the book, then there is a tons of imagination. If this rectangle maps one coordinate to another coordinate, and in one coordinate if there is a rectangle, then it maps to other coordinate, and imagine that it is a parallelogram. This imagination of delta, and delta tends to 0, when delta tends to 0, then a shape becomes a parallelogram, a curve becomes a straight line. This kind of calculus killed calculus, because if you proceed in wrong way, then people will not incline to learn it, because it will become something that may not be true. You are getting the result, that's why you are proceeding through that way. That's why we are here. We are here not to read any book that it is written in the book and this is how it is. We are here to give kind of the correct path of the understanding. So where from this Jacobian and those stuff came, that we have talked about. Like if I have a xy plane, if I have a xy plane, x-axis, y-axis, z-axis. This z-axis is function over x-axis and y-axis, rather xy plane, fxy, f, small f, bracket open, x comma y, bracket close. This x comma y is also called xy plane. There is one independent component, that is xy plane. Area is independent component, not the line. Z, that is fxy, function over x and y, is dependent upon xy plane, not x and y. Xy plane is dependent upon x axis and y axis. This is like that. So z axis is dependent upon xy plane. Xy plane is independent for z axis, and xy plane in turn dependent upon x axis and y axis. In parameterization, this x axis and y axis is again dependent upon another independent component called u and v. So xy plane, indirectly it is dependent upon uv plane. This is parameterization. X equal to function over u comma v. Here z, height, function over x comma y. Here x is function over u comma v. Y is function over u comma v. Or xy plane is dependent upon another plane called u comma v. UV plane. In 3D, Jacobian, that we will see, there is XYZ volume. So XYZ volume is dependent upon UVW volume. Okay, so this dependency, or you can match it something similar to chain rule in differentiation. Chain rule in differentiation, where step by step this chain rule is highly usable in calculating the fixing or settling down the matrix data in neural network in machine learning. This kind of chain rule in error. So chain rule, slowly it goes step by step. Similar to that, we go step by step. Fxy, z is dependent upon xy plane. Xy plane is dependent upon x-axis and y-axis. X is dependent upon u and v-axis. Y is dependent upon u and v-axis. Or indirectly, xy plane is dependent upon uv plane. This is parameterization. Parameterization in the sense problem is in xy domain and now we are using uv domain coordinate system that is separate and x is a function over u comma v. This is parameterization. X equal to g u comma v. G u comma v is parameter in a function g and x is dependent upon them. This is parameterization. Y equal to h u comma v. Like if we are calculating volume of a sphere, if this is xy plane and there is a sphere that is centered at the origin on the xy plane, the upper portion of the sphere, that is hemisphere. If I am trying to calculate volume of it, then it is, if I have reiterated. So if I have x-axis and there is a curve like this, curve line, if I want to find, if I integrate this curve along x-axis, this curve, when it comes down and touches the x-axis, whatever the area I am seeing, it results in that area. Similarly, if I have a surface and this is xy plane, surface, if it comes down and touches the xy plane, whatever the volume I am seeing, that is fxy dxy plane. So that is the volume of the surface. So if I am trying to calculate the volume of hemisphere, then fxy dxy plane and the region what we are saying, that is the region. If this is xy plane, if this is xy plane and this is the surface, then surface will map to a region on xy plane. This is the region on xy plane where the surface would touch. So xy must be confined to this region. It cannot go beyond this on xy plane. So that region is the region of integration. So that region, and then the surface equation fxy, that is square root of a square minus x square minus y square, because x square plus y square plus z square equal to a square as per the sphere. Z is equal to square root of a square minus x square minus y square dxy plane or dx dy. Now, if I take help, if I am not able to do it, I would take help of another coordinate system that is called u and v, where u and v, where the x equal to v cos u, x equal to v cos u and y equal to v sin u. Someone can say r cos theta and r sin theta, where uv is r theta plane. Uv can be anything. Now change it to r theta, people understand better. So x equal to r cos theta and y equal to r sin theta. We can consider r as v and theta as u. It is x-axis is theta and y-axis is r. Theta r plane, uv plane. If that is the case, then I can replace it. Now it becomes a square minus x square minus y square. It would change it to a square minus r square, square root. And then region, what we are saying, the circular region, because the sphere, hemisphere will fall on xy plane and it will make a circular region on xy plane. That circular region now, that theta is 0 to 2 pi and r 0 to a. A is the radius of the sphere. And dx dy, dxy plane has to be mapped into uv plane, r theta plane. But it cannot be dx dy. I would say dx dy, x and y are Cartesian. There r theta plane is also Cartesian. Theta is x-axis and r is y-axis, horizontal and vertical. It is also a Cartesian plane only. If that is the case, then can I replace dx dy with dr d theta? I can replace if x equal to cos theta and y equal to sin theta, then dx equal to minus sin theta d theta and dy equal to cos theta d theta. Just replace dx dy with whatever you see. But it is not true. X is variable. X is dependent upon R and theta both. Both are independent. R and theta both are independent. Y is dependent upon R and theta again. So x equal to g r comma theta in braces. H y equal to h r comma theta. Dx dy, that is xy plane, cannot be directly changed into uv plane du dr d theta or d theta dr, because there is a relationship between x y with r theta, and that is as r cos theta r sin theta. It is not that straightforward. Then what would be replacement of dx dy to d theta dr? Here, Mr. Jacobian comes into the picture, that I have the solution. So, first solution that we have proposed is dxy. Dxy plane is nothing but dxy by duv into duv as per multiplication. So, duv I can now silently keep as d theta dr, the way it was dx dy d theta dr. What about dxy by duv? Dr theta, dxy by dr theta. This factor is called Jacobian. Dxy, d small d braces x comma y braces close by d small d braces u comma v braces close, or d theta comma r braces close. Dxy plane by d theta r plane. What is the value? That is the extra that will be attached to the dr d theta. So dx dy, dx dy will be converted to dr d theta, and extra is Jacobian that will be attached to it. So if it is single dimension, if I need to change dx into d theta, then I can silently like consider x equal to a is constant, x equal to a cos theta, then dx equal to a minus sin theta d theta. Similarly, very simple, then dx by d theta equal to minus a sin theta. Silently I can replace dx with the minus a sin theta, and d theta is anywhere. This is single Jacobian. But dual Jacobian is not that straight. Then we have to come to vector analysis in dual Jacobian. So for dual Jacobian, consider for dual Jacobian, okay, for dual Jacobian, consider I have a sphere. I have really a sphere. Okay, for dual Jacobian, consider this is xy plane. This is xy plane, and there is a sphere. A sphere is nothing but it's a surface. It's a spherical surface. Okay, now this is xy plane and this is a sphere. If this is a sphere, if this is a sphere, then consider any point on a sphere at xyz. If this is xy plane, then there is x comma y on xy plane and height is z. So any point is represented as x comma y comma z. If that point is P, then its position vector is xi plus yj plus zk. Okay, then it is xi plus yj plus zk. Okay, leave this fundamental. Now, if I have a, consider any plane, xy plane, I have a vector like this. This vector is a vector, alpha vector, and there is another vector like this. So, there are two vectors. There are two vectors. This is one vector, this is another vector. Okay, one vector is alpha and one vector is beta. What is alpha cross product with the beta? Alpha vector cross product with the beta. Then this will make a parallelogram. If you see, then if I can take a line that is parallel to this line, this line and parallel to this line, it will make a parallelogram. The cross product of these two vectors is area of the parallelogram. Like one vector is the beta vector is I plus j and alpha vector is I, that is x-axis. I is unit vector, j is unit vector. I plus j is not unit vector. But anyway, what is cross product of I plus j cross I? Then it will come as minus k. J cross I is my I alpha cross beta. I cross I plus j. It will be k. So magnitude of k is 1. The area of the parallelogram is 1. Is it really 1? Okay. Is it really 1? So if I have I vector and I have I plus j will be 45 degree. So I plus j 40. The area of parallelogram is base by height. What is the height? So if base is 1, it is 45 degree. Then when x-axis is 1, then height will be for ij will be 1 only. So the area is indeed it is 1. So correct. So area between any two vector is cross product of these two. So if I have alpha vector, beta vector, if I do cross product of alpha cross beta, then it will result in the area. Okay. Now I have x. Now we'll go back and I have a point P here, xi plus yj plus zk, whatever. This vector is called P vector. What about dp by dx? This is our solution. Please support us. Okay. What is dp by dx? dp by dx, it is xi plus yj plus zk. It is I plus dz by dxk. If a vector has component as I and k, means it is x-axis and it is z-axis, then this vector will hang somewhere in xz plane. What about y? Now p equal to xi plus yj plus zk dp by dy, then it is j plus dz by dyk. Now this vector will hang in yz plane. So at any point P, the cross product is dp by dx cross dp by dy. Forget it. I am saying dp by dx equal to I plus dz by dx k. Consider this is a vector at all. Forget it is dp by dx. Consider there is a alpha vector equal to I plus dz by dx, whatever value comes, k. There is a beta vector that is j plus dz by dy k. One is in xz plane and one is in yz plane. Now there are two vectors. If I calculate, it is something like this. You can see like this. If I calculate cross product, it will give me the area in between. Now someone will say that alpha vector, what you said, I plus dz by dxk, and beta vector j plus dz by dyk, actually it is simply area, the cross product. Okay. So alpha cross beta is an area, but underneath alpha is not simple vector, it is dp by dx and beta is dp by dy. Then it is an area, but behind the scene, the area of what? Earlier alpha and beta, then area was alpha and beta plane. If there is a one vector alpha and one vector beta, if I consider alpha beta plane, then this is area of this. This is what plane? This is not x-axis or nor y-axis, that it is xy plane. It is rather dp by dx and dp by dy plane. Can you see that? So it is nothing but surface d surface by d xy plane, dp by dx cross dp by dy. If you see, the numerator is surface area per xy plane as per division. What is xyy? If I say division of xyy, then amount x per y means if it is what is 10 by 2, that is 5. Okay. So per, I mean, there are 10 apple and 2 oranges. 10 apple and 2 oranges. How many apple per oranges? 5. 10 by 2. Per orange there is 5 apple. That is division, right? If there is dp by dx per x, how much p is? Per y, how much p is dp by dy? dp by dx cross dp by dy, if numerator is giving the surface area per xy plane, because down it is xy. So surface area per xy plane, it is not pure surface area, it is velocity vector. Surface area per xy plane. So calculating for the per xy, not per x or per y, we have to do cross product, because cross product generates area vector. Can you see it? Area vector. So dp by dx cross dp by dy is d surface area per dxy plane. If that is the case, then we calculated it. So if I have xy plane, on xy plane, if I draw a rectangle, xy plane, if I draw a rectangle, this rectangle would go and map to some surface region on this 3D model, this surface. Or if I have a surface region on this model, this surface region, if I go take it down, it will map an rectangle on xy plane. If there is this surface, if this surface region has area A and rectangle has area xy, then this is dA by dxy. So dp by dx cross dp by dy is nothing but d of surface area by dxy plane. What is this? Means dxy plane we have rectangle. Means if I have already a rectangle in xy plane, if there is a unit change in rectangle, d surface area by dxy plane xy, two things are there. Two things means area, not line. So if there is a unit change in the area of rectangle, if area of rectangle is in meter square, if there is a change in meter square, okay, there is a 1 unit change, 1 meter square change, 1 unit change, it can be 1 meter, 0.1 meter, how much you take as 1 unit, or infinitesimally small. If there is 1 unit of change in this rectangular area, brings how many unit of change in the corresponding surface area, d surface area by dxy plane, where surface area is nothing but dp by dx cross dp by dy. So at this point dp by dx is like this. At this point dp by dy is like this. Can you see? So this is the surface area in between it. On top dp by dx is flat. In fact, there is no dp by dx, 0. And it's very small. dp by dy is like this. So there is no surface area at all on the top. 0, 0. Means on top of the sphere, okay, probably there is no surface area or something like this. It's a point. But if you come down, there is a surface area, whatever. Anyway, so if I see here, then dp by dx is like this. dp by dy is like this. Like this. So the area vector starts changing like this. Can you see? On top it is pure k, and then it is area vector is changing like this because dp by dx cross dp by dy. That results in minus dz by dxi minus dz by dyj plus k. So points where dz by dx is 0, dz by dy is 0, then it is only k, that is the top portion, only k. Otherwise, it will have some value. Okay, so now we learned the d surface area by dxy plane, how to calculate. Now, when you see the original question is dxy by duv plane, d theta r plane. Now, this is uv plane and this is xy plane. If there is a rectangle in uv plane and this rectangle is mapped to xy plane to some area, if there is a unit change in this rectangle, brings how many unit change of area in this uv plane? Dxy in xy plane. UV plane. In UV plane, there is a rectangle and 1 unit of change. Rectangle is not of 1 unit. There is change of 1 unit. 1 unit is growing or coming back, lessening. Then how much of unit change in area, meter square, in plane on xy plane, dxy by dv, dxy plane by duv plane. Or earlier this was xy plane. Now consider it as uv plane. If this is xy plane, now it is uv plane. This uv plane is mapped to a surface. This is xy. That's why x equal to g u comma v, y equal to g u comma v. Earlier z equal to fx comma y. Now this uv plane is mapped into xy plane. Okay, what about dxy by duv? Earlier dpy dxy. So dxy by duv, if I represent this xy plane and uv plane, if there is a rectangle on uv plane, if I make a small 1 unit of change in this rectangle, if this rectangle mapped into some surface region area on xy plane, how many unit of change I see in xy plane? Consider there is a point on xy plane called x point as x comma y. Then position vector is xi plus yj. Now dxy by duv plane, this is what we are trying, right? Dxy by duv plane, dxy plane by duv plane, where 1 unit of change of the rectangle on uv plane, how many make how many unit of change in uv plane, in xy plane. Then dp by du cross dp by dv, simple, right? So the p position vector on xy plane is xi plus yj. Then dp by du is dx by dui plus dy by duj. And then another one is dp by dv. Please support us. This is our proof. And this is completely error free. No imagination. Okay. dp by dy, dp by dv is dx by dvi plus dy by dvj. Now, if I do cross product of dp by du cross dp by dv, then it will become dx by dui plus dy by duj cross dx by dvi plus dy by dvj. Now, it will settle down as dx by du into dy by dv minus dx by dv into dy by du, k vector. Okay, so this is called Jacobian, dxy by duv plane, dxy plane by duv plane. That is nothing but the cross product of dp by du cross dp by dv, dx by du. Now I can keep in a matrix and calculate the determinant. I can say I, j, k, and in second row dx by du, dy by du, 0, dx by dv, dy by dv, 0. And from k I can take the determinant. Then multiplication of the cross and minus. Okay, then what is the second proof? Now bookish way of the proof. Now bookish way is that if I have, now there are two bookish proof. Both are similar only because books think in similar fashion, or internet you will find this kind of proof. So this is UV plane and this is XY plane. On UV plane, consider there is a big rectangle, and rectangle is divided into n subsection on x-axis, n subsection on y-axis. So there is n into n subrectangle. Any subrectangle I consider as ij, ith, jth. If that subrectangle if I take, then bottom left corner is u comma v. Okay, and that subrectangle has width as delta u, height as delta v. Then the if bottom left is u comma v, then bottom right is u plus delta u comma v, and height is u comma v plus delta v. Now this subrectangle is mapped into a region in xy plane and with a function x equal to guv, y equal to huv. If that is the case, then here it will map, this subrectangle will map to a parallelogram because it is very small. There is a problem. What is the guarantee that this subrectangle will map here to a parallelogram? Consider it. Imagine, it is so infinitesimally small. Imagine delta u and delta v, the width and height of subrectangle, that it will map to a parallelogram.